I saw this question on YouTube, and I have my way of doing it. It's a very different and very unusual. It's worth sharing here. Now, we are looking for x. Now, x must be a complex number. Now, my consideration is started uh, from this. This these two complex numbers must be symmetrical with respect to the real axis because the this one has a no imaginary part. So let me see. Now, how about this? I'll let C1 be this and C2 be this. These two complex numbers, the sum is 32. Okay, so this is not possible. C1, C2, this is not possible because the sum of the real part is 0. It's not 32. This is C1, this is C2. The imaginary part is 0, but the real part is negative. So this is not good. C1 is here, C2 is there. The sum is negative. It's not good. This C1 and C2, the imaginary part is 0. The sum of a real part is 32, which means this is 30. This means 16. This is 16, right? Which is possible, which means that x plus 1 is a plus or minus 2, right? Which means x plus 5 is plus or minus 2, yeah. Okay, this means that x is equal to minus 3 or plus 1, right? This means that x is equal to minus 3 or minus 7. So we choose the common factor as x equal to minus 3, which is possible, b equal to 0, right? So therefore, one solution is that x equal to a plus bi. I have found one solution already. A is equal to minus 3, b equal to 0. That is a situation when these two complex numbers landing like this. This is C1, this is C2. This is one possibility. Now, the other one, okay, this is not possible. This is not possible. This is not possible. That, yeah, I think is possible. Right? This is x plus 1 fourth. This is x plus 1 plus 5. Okay, fourth. Which is possible because the sum of a imaginary part is 0. And the sum of a real part is 32. This is 60, right? If this is the case, then they are equal, right? This length is equal to this length, right? So what is this length? This is equal to what? X equal to a plus bi, right? Yeah. So this one means that a plus 1 square plus b square, right? Because this square root is the modulus. Then the fourth part becomes this. This one is equal to a plus 5 square plus b square. If they are the same length, which means that a plus 1 square plus b is equal to plus or minus, right? A plus 5 square plus b square. Yeah. Yeah, this is equal to that, right? Then, yeah. Then this one's a square, a plus 1 square plus b square equal to a plus 5 square plus b square. Yeah. And which means that a plus 1 is equal to minus, because plus is not possible. It's minus a minus 5. So a is equal to minus 3. Yeah. So a is minus 3. And we're just looking for the b, right? B. What's b? Now, we find a is minus 3. Okay. X is equal to a plus bi. A equal to minus 3. Now, this means that which means x plus 1 is equal to minus 2 plus b I, right? X plus 5 is a 2 plus bi. So which means that this is b, this is b, this is a 2, this is minus 2. Okay. So this is situation. This one is 2 plus bi. This one is minus 2 plus bi. Okay. So these are two numbers, two complex numbers. Okay. Now then the theta is equal to is cosine. No, let me put it this way. Cosine theta, this is better. Cosine theta is equal to 2 over square root 4 plus b squared, right? Yeah, that's better. Okay. Well, negative theta is the same thing. Negative theta, because cosine negative positive is the same thing. So that is cosine theta. And this is 4 theta. So negative 4 theta. Why? Because the fourth power, by using the Moore theorem, right? Fourth means the argument is 4 times. 4 times this argument. 4 times. This is argument for x. Okay? This is x, right? Yeah, the square root. Okay, I'm sorry. The square root. Yeah. That's the modulus, the square root. Square root. Square root of 4. Yeah, plus bi. Okay. I'm confused. Okay, let me put it this way. Again, this is 2. This is b. This is 2 plus bi. This is a complex number. This is another complex number, is 2 minus 2 plus bi. This is a complex number. The length, the modulus, is equal to The modulus equal to 4 plus b squared. That is, yeah, that's better. And this length is 4 plus b squared. That's this length. The modulus of this complex number. This length. This is a complex number. And this is the argument, which is a 2 over that. Negative, the same thing, okay? Cosine. So cosine theta is equal to 2 over this length. This is this. What is this? Now let's come back to this. Okay, this is a complex number 4 times, fourth power of this, right? This length is equal to, well, is equal to, we know that a is equal to minus 3, right? So this one is equal to 4 plus bi fourth time, right? This becomes square, yeah. This is square root 4 times become this. This is 4 plus bi square. Square root 4 times is this. I hope it makes sense. Now this is the argument. The length is this. The complex number is this. Okay, this is the angle 4 times. Now then we have a. Let me put it this way. Okay. This is x plus 1 fourth time. This is x plus 5 fourth time. This length is 4 plus b square square. This length is 4 plus b square square. This angle is 4 theta. This angle is 4 theta. Okay. This is 16. Okay. This is equal. Therefore, no imaginary part. The sum is 0. All right. Now, I think, well, what excitement. So now I know that this length, b squared, this is this modulus, right? Multiplied by cosine 4 theta is 16. This is 16. 16 okay? Makes 32, right? Makes 32. And what is cosine theta? Cosine theta is this. Yes, okay, it's still there. It's good. We have a formula, cosine 4 theta is equal to 8 cosine 4 theta minus 8 cosine square theta plus 1. So that is the fact. Wow, which is the trigonometry, right? Now we can use the formula. Wow, what excitement is this? Now, this one square, 4 plus bi square square, multiply cosine 4 theta, which is this, right? Times 8 cosine theta. Cosine this fourth because 16, right? Becomes 4 plus b square square. That is it. Fourth power. And minus 8 times this is square. This is square is 4. Square is 4 plus b, right? Plus 1 equal to 16. Yeah. Yeah, I'm using this formula. This one, yeah. Now then, this one goes in. It becomes 128, right? This time this is 128. This is cancelled out. Minus 32 times, this is cancel one of them, plus 4 plus bi squared is equal to 16, yeah. So this is 4 plus b square minus 32, 4 plus b square plus 112 equal to 0. So that's quadratic formula for b square is half 32, huh? Sorry, 32 minus b plus or minus b square. B square is 32 square, right? Minus 4ac. 4ac is a 448. Well, this is equal to 2. 32 plus or minus the square root 576. So 4 plus b square is equal to 6. 32 plus or minus, this is 24, which is good. So it's equal to 16 plus or minus 12. So 4 plus b square is equal to 4, right? Or 28. So b square is equal to 0 or 24. So b is equal to 0 plus or minus 24 square root is 2 root 6, isn't it? Ah, I found a b. So x is equal to a plus bi, right? So this is equal to, I know, minus 3 plus or minus 2 root 6i. Ah. And plus the previous case, so x equal to minus 3 plus or minus 2 root 6i. So these are solutions to this equation in the beginning. Well, I think I'm using very unusual way to find the solution. I don't know. I haven't seen anybody did it. Anybody did this way. I deserve the credit.